Project 2.3 Matrix Animation. This project is one that allowed creative designs and animations or characters to be displayed on an 8x8 mini matrix to techniques such as persistent vision, bit shifting, multiplexing, timers, and EEPROM. Now, let's break down the circuit by looking at its prototype. Essentially, each part of the prototype corresponds directly to a part on the main circuit. For example, this ATmega 328P chip is directly corresponding to the Arduino Nano and is set up in the same configuration as the Nano, whereas the Matrix Made Easy PCB is essentially this part over here, which is connected with the same two shift registers and the matrix. Inside this circuit, the ATmega 328P microcontroller is essentially the brain. It has 32 kilobytes of flash memory, 2 kilobytes of RAM, and 1 kilobyte of EEPROM. EEPROM is essentially the main focus of the project, as this is the part where the animation and frames will be stored. The EEPROM, or electrically erasable programmable read-only memory, stores the animation frames, even when the system is powered off. And this is very useful because the data remains intact, so you don't need to reprogram every single time. And each 8x8 matrix animation frame uses just 8 bits, making the EEPROM capable of storing over 100 frames. Now, let's talk about the shift registers. There are 2 shift registers used in this project, which is the 74HC595 and the TPIC 6C595 power shift register. They work together to control the matrix. Inside this circuit, the 74's HC595 manages the logic level signals, while the TPIC 6C595, with its high current capability, drives the LEDs. These components reduce the number of microcontroller pins, allowing the ATmega 328P to handle the entire system with just 3 pins through a process called multiplexing. Inside the program of this project, bit shifting is another very essential technique. It essentially manipulates the binary data to control specific LEDs on the matrix. By shifting a bit to the left or shifting a bit to the right determines which column or row in the matrix is activated. This method simplifies the programming and reduces the processing load or the strain on the microcontroller. Now let's talk about the timers. There are 3 timers that exist in the ATmega 328P, and they are timer 0, 1, and 2. Inside this project, we essentially used the timer 1 to replace all the functions that was previously using timer 0 to allow a more accurate and sophisticated control of the intervals between the frames. This is done through the use of the timer 1 library. And it essentially allows the microcontroller to display frames at consistent intervals. And the potentiometer, which is right over here inside the final project, adjusts the time settings, allowing you to control the speed of the animation in real time. That's it for Project 2.3. Thank you very much for listening.